Hi everyone. We left off on page 116 and we were talking about distributions of sample proportions. And in number 18, we're looking at if we had a random sample of 80 Reese's Pieces, would it be surprising that more than 65% of the pieces in the sample were orange? So one way to determine that is to find the z-score. And if you're more than 2 standard deviations away, we would say that that would be surprising because it would be rare or unusual. So it's not impossible, but it's improbable. So if I was to find the z-score, I'm finding my value minus the mean over the standard deviation. So here, my value is going to be 0.65, and the mean is 0.50, and the standard deviation that I found is 0.057. And that was from using the Rossman applet. And this comes out to be 2.6316. So this is more than 2 standard deviations away from the mean. So it would be surprising to find 65% of our pieces to be orange. And you can even see 65% is not even on our model. So that would be somewhere down there on the model. So yes, it would be surprising. When you return to the applet, if you haven't had a chance to go to that, you want to try that. You can leave n equals 80 and p equals 0.70 and take 500 samples. If we were to estimate the center, when I did this on my own, I got the center, so I used x bar, which is the sample average. I got 0.698. So although the sample proportions vary from sample to sample, they seem to pile up around the population proportion. Which in this case is P, which is your mean, 0.5. So if you'll think about all those the dot plot, all of those points kind of piled around 0.5, which is the actual proportion of orange Reese's Pieces. So in summary, when we have random samples taken from a population, the sample proportions vary because not every sample is going to be the same. And it's difficult for us to predict the value for any particular sample. But when we take lots of samples, we have a predictable distribution. The sample proportions will cluster around the population proportion, which again is P. And the larger the sample size, the less the spread of the distribution. So we talked about how the standard deviation decreases when the sample size increases. The mean of the population, or the mean of the p-hat sampling distribution is P. So again, what is this p-hat sampling distribution? That's just all of your bags of Reese's Pieces and all of the orange Reese's Pieces that were contained in each of those bags. So all of those bags, if I was to dump them back together, came from that huge bag of Reese's Pieces. So think of a sampling distribution as just a distribution of averages. We found in each of your bags the average orange Reese's Pieces in each of them. And when I took all of those averages and plotted them on the dot plot, they all clustered around the population proportion, which was 0.50. And that's what we wanted, because we wanted to use the sample to estimate the true proportion of orange Reese's Pieces, which the company says is 50%. And even using our small sample size, we were able to see that it does cluster around 0.50. Now, when you're trying to find the standard deviation of p hat, that's a little different. And when we find the standard deviation, we're going to use this formula here. It's also referred to as the standard error. So it's not an error in that it's a mistake. It represents the variability that we expect to see from sample to sample. So when you find the standard deviation of p hat, it's equal to the square root of the population parameter, or the population proportion, times 1 minus the population proportion, all divided by n, which is your sample size. Now, lucky for us, when the sample size is large enough, the p hat sampling distribution will be approximately a normal distribution. So if you think of the dot plot that I did, let's pretend this is 0.50. What happened is all of the values you all gave me were your p hats. And if we were to keep increasing the sample size, it would come out close to a normal model. So that's helpful, because now we can use things we know about the normal model to answer questions. So this first question says, suppose that a large community college, 60% of all the graduates are female. Imagine that many random samples of graduates at the college are taken, with each sample having 150 graduates, and for each sample of 150 graduates, the proportion of the sample that are female is recorded. Answer the following questions. Okay, so I want you to think about that first of all. Pretend we're talking about Valencia College. If I was to keep taking random samples of 150 graduates, I would want to try to determine the true proportion of female graduates. So if I kept taking samples over and over of the same size, the percentage of females that graduated within each sample represent my p hat. And all of those p hats, your sampling distribution, will cluster around the population proportion p. So the first question says, write a sentence giving the meaning of the symbol p in the context of this situation. No numbers are allowed in this sentence. So here, p is going to equal the population proportion of all graduates at the community college that are female. The numerical value of p in this problem is 60%. So that's 0.60. To calculate the standard deviation of the sampling distribution of the sample proportion p, we need to find the standard error. So if you'll recall, the standard error is just finding the standard deviation of p hat. And the way we find that is by taking the square root of p times 1 minus p over the sample size. So if I want to find the standard deviation of my sampling distribution, p here is 0.60, and I'm going to multiply that by 1 times 1 minus 0.60 over my sample size. So n in this problem is 150 graduates. That's my sample size. And we're going to use this formula to estimate what the standard deviation is, because it's unknown. When you multiply all of that out, you'll get 0.04. So that would be my standard deviation of my sampling distribution, or my standard error. So think of it like this. Your standard deviation, your mean rather, p is 0.60. So that's the true average of proportion of female graduates at this college. All of those p hats, if I keep taking samples of 150 students that have graduated, all of those p hats will cluster around 0.60, and a large enough sample will give me a normal model approximately. So my standard deviation is 0.04, so I'm just going to keep adding that to 0.60. So 0.60 plus 0.04 is 0.64, plus another 0.04 is 0.68, and then go backwards, you would get 0.56 and 0.52. And eventually you'd have a normal model. So then you can estimate, for instance, like here and here, that's 95% of the females who graduated. When it says here, you're looking to determine the proportion of the sample that are female. So you could say 95% of the population, right? 95% of the samples that you took would contain anywhere from 0.56, so 56% of female graduates, to 68% of female graduates. So 95% of those samples would have those percentages, anywhere from 56% to 68% of female graduates. The next problem asks us to sketch the normal distribution that approximates the p-hat sampling distribution, so that's what I just did. So we've got 0.60, and then they want us to go 2 standard deviations out. Suppose that a random sample of 150 graduates had 99 females. Mark the sample proportion on the sketch in question number 23. Okay, so to find p-hat, I would just take 99 and divide it by 150, and that gives me 0.66. So 0.66 is like right about there. If a random sample of 150 graduates were selected from the college, would it be surprising that less than 50% of the sample would be female? Well, if you look at the graph that we created, 50% is down here, which is more than 2 standard deviations from the mean. Here's the mean. This is 1 standard deviation, 2 standard deviations. So yes, it would be surprising. And remember, the mean is the population proportion, P. Okay, the rest of the notes is the homework. Please take the time to work on it, check your answers on the selected answers, and then, Monday, if you have any questions, I'll be more than happy to answer them.